I have open the paper on the perceived stress before and after doing the online mindfulness course, and also the data that goes along with this paper. So what we're going to look at is doing a paired t-test to see if there is a significant difference in the stress before and after doing the online mindfulness course. And we're not going to consider the follow-up for this particular example. And what we're hoping to find, obviously, is the same as what they find in the paper, that we have this significant drop in stress. Now, as far as this paper goes, we should be able to get the same graph here, and actually I think we can do it better because they don't have any confidence intervals around those means, and I think that would be valuable to put them on. So in the data, you'll see that we have the stress pre and the stress post. The stress post one is that follow-up measurement, which we're not interested in this case. Now, there are some assumptions that go along with the dependent t-test, which are very similar to the assumptions for the independent t-test, but because the data is structured differently, it actually is a little trickier to get the plots out. Now, you can see here I've already done the plot of the means and the confidence intervals, and I'll take you through those, but normally we'd probably start with a histogram and some box plots, but what you'll find is it's actually very difficult to do that with the paired data. So I'll take you through your options. So with your chart builder, if you're interested in a box plot, I'll reset that. If you had independent groups, you would drag your outcome measure onto the y-axis, and then you would drag your groups down here. Now, with some of the graphs, you can get SPSS to create the groups by dragging the extra variable into the y-axis as well, but it won't let you do that in this case. So you could look at the box plots individually for this, but actually what we're interested in terms of doing the test is not each of these distributions by themselves. What we're interested in is this difference. This person started at 28, they ended up at a stress level of 16, and so what was that drop? So really what we need to do is get an extra column of differences. Now, for this example data set, I actually already went through and did this, but I'll just quickly show you how to do this. If you're not comfortable working with SPSS, although it does work just like a calculator, you can obviously do this in Excel with a formula. So to get an extra column, which is calculated from two other columns, we go to transform and compute variable. So you're looking for that little calculator function. The target variable is this thing that you want to create, so you just need to give that a name. So difference in stress, and you can call that anything you like, but being SPSS, just remember that you can't put special characters in there or spaces because it doesn't like it. And then we just want to type in the expression that we're using. Now, it's up to you which way around you do the subtraction. We're interested in either pre-subtract post or post-subtract pre, and it doesn't matter which way you do it. It just means that you have to be careful how you interpret it. In this case, because there was a drop of the stress, I am going to do the pre-stress, so I'll select pre and put it in, subtract, post, and then I'll know that whatever number I get out here is the drop in stress. If anyone gets a negative difference, that means they've actually increased their stress. Press OK, and then you'll see we have this extra column come up, which is exactly the same as my other column of differences, obviously, because I've done this once before. So in terms of looking at the assumptions for the dependent t-test, what we're interested in is this column here, the difference in stress levels. Does this have any outliers, and is this approximately normal? So back to the graphs with our box plot, we can now drag in that difference. Press OK. And we do have a couple of outliers, but the rest of it's looking okay and they're not too extreme. So, and the test is fairly robust, so I think that will be all right. And then we might look at the histogram. And actually it's kept the variable there too. And again, we can see the same pattern. I probably should have put the normal curve on that. Okay, apply. So it's not quite normal. We do have a few more than we would expect up here, and we've got those couple of outliers, but that's not too extreme, and I think the test will be fine in this case. Now the other graph that we can do, which I started off with, is that graph with the means and the confidence intervals. Now this one you can do with the pre and the post. So I'll reset that. I'll drag in the error bar chart. Now normally we would put our outcome variable here, and then we would put our groups down in the x-axis. In this case, because our groups are actually in separate columns, as in the test they did, take the post value and we'll just hover. Now you've got to hover over the top of it so until you get that plus sign, and then it will add it to the graph instead of replacing it. So I add that in there. It says it's going to create the groups, and OK. And then we get this graph with the pre and the post. And in the paper, obviously, they had the follow-up, 1 month follow-up or 3 month follow-up, whatever it was as well. So I think we can tell from the data that the difference pre and post is positive for most of the participants. So they've had a reasonable drop. There's a couple of people that had higher stress afterwards. From this graph, it looks like we're going to get a significant result, and of course it doesn't take long to just run the test. So for the paired t-test, we'll go to Analyze, Compare Means, and the paired samples t-test, and we can do, again, it doesn't matter which way around we do these variables, you just need to be careful how you interpret the results. So just check you know what the difference is, and OK. So what the output is telling us here, we had a mean stress before of 23.7 and a mean stress after of 14.4. The mean difference is 9.3, and that's very similar to what we can see on this histogram. Obviously it's hard to estimate the mean accurately just off the histogram when we've got these funny bumps and outliers, but it's sitting around the middle here, 9.3. So the mean drop in stress was 9.3 points on whatever scale they're using. Our test statistic is here, 14.7, and this is highly significant. We've got a very small p-value. So this is the t-test, and then in the next video I might also look at how this is related to running a simple linear regression, which you could also do with this data.